Hello, everybody! Welcome to week 3 of the Data Science course by Machine Learning Grads. I am Aegis Pataru, data scientist at No Center, and I am with
Bogdan Andrusak, and I'm a data scientist at Kleine Zeitung.
And this week we're gonna talk about fundamental algorithms in data science. But before we're gonna go about this topic, most of you did the assignment from last week, and I must say, Bogdan, I'm so impressed of our future data scientists. They really did a great job. And today we're gonna show some of people examples. Now, unfortunately, we don't have time to go through everybody's, but what I saw, a lot of people came to the same conclusion, which means great minds think alike. And I guess let's go into this one. So, some of you submitted a presentation. Some of you submitted a Python notebook. Both are fine. And I guess we can go through one of them, which I liked. So this one from Angela Faisal. She did the following. So first, she answered the question, what is the most profitable chain and city? And what I like is that not only she created like plots, not only like getting the data in a data frame, also plotting it, which most of you also have done, but also describing in the notebook very nicely, like here. And most of you got it right. Salzburg was the most profitable city here. Furthermore, most of you also looked how effective the membership program was and also deducted the right conclusions. So in this case, it was effective. And also about like what male and female members buy, most of you also got this right. So excellent job, all of you who did explored this subject. So, and finally, yeah. So this is a really great one, and most of you did something like this, and great job, all of you. Like really good. I'm so proud of you. Really proud of you. Some of you made also PowerPoint presentations, and this one was amazing. So Bianca and Bernhard, you did amazing job. So this is a PowerPoint presentation for the CEO, and it's what I like. It's that they actually took the principles which we talked about last week and adapted those plots with those new design elements. So we can see here very simple, clear plots, editing the default style from Plotly. Also, very nice using of maps for representing profits, creating their own map with this. Really great way to communicate that Salzburg is the most profitable city. Also, with the membership program, it's not perfect. However, this box plot is quite clear. Not sure about the histogram plot. And finally, yeah, so these plots which were also done by Angela, also very nice. I also like this table showing what are the most successful products among men and women. And yeah, really great job. So really good, same conclusions like most of you did, but just in the presentation form. Really good job, everybody who did something similar to this. What I also like, some of people ask some unusual questions, like how many taxes did we pay? And OSDev really explored this question, which I found very nice, a very nice touch. And finally, I am also disappointed to some of you people. You pinky promised that you will never do 3D plots, especially these 3D pie charts, to impress your managers. When you pinky promise, it's like life and death. You cannot break it. So this is your warning. This is your last warning that if you pinky promise, you lose your your honor as a data scientist. So please be careful next time. Okay, this is not a joke. So anyway, great job everybody who submitted their assignments. So now let's go back to the course. So first, I want to ask you, how are you feeling? And for this, you can go on AHA Slides/week 4 and tell me how are you feeling. So as usual, you can either open it through your phone or through your laptop, open a new tab, go to AHA Slides.week 3, and just answer and tell me how you feel. Bogdan, how are you feeling today?
Feeling great. As always, excited for what we're gonna teach today, what people will learn, and really looking to jump right into it.
And also, some people already experiencing some are sleepy, some are tired, some are Gucci. Some people are excited. Some are enjoying having the luxury, enjoying sitting in the garden. Motivated people. Some people enjoying their Easter eggs.
Nice to see that people are feeling good and ready to learn something new today. Oh, somebody is sad. I hope after this course you will be all excited.
I hope quarantine is the quarantine is almost over. That's the good news. So I think opportunity to be happy again, possibility to go outside is very soon.
Yeah. Oh, there is a question to our question about assignment. Yes, you can submit all assignments till like last assignment. So together with the final project.
Yes. So more about that, we're gonna talk about it. So don't worry, we're gonna answer that question about more into detail today. Okay. So the agenda of today is we're gonna talk about machine learning, about a library called scikit-learn. We're gonna talk about decision tree, which is a machine learning algorithm. We're gonna talk about evaluating those algorithms. And also, I'll talk about random forest, which is another machine learning algorithm. Okay, we talked about the assignments. That was great. Good job, everybody. So, someone asked regarding the assignments. In this course, if you complete the course, you will get a certificate. So, if you do all the assignments and also the final project at the end, you will get a certificate which you can add on your LinkedIn profile. So even though you did all of your assignments now, it's not a big deal. You still have time, but you have to finish all assignments, including the final project, to get the certificate. And I think we're gonna talk more about it maybe next week. But just so you know, you can get a certificate. We're gonna also do some exercises, so we're gonna need you to take some pen and paper. Also, maybe get your calculator. Most likely you need the calculator more than the pen and paper. And we're gonna need that also. So I think enough introduction. Let's talk about machine learning now. So what is machine learning, Bogdan?
Well, machine learning is very complex study, and the goal of machine learning is to make algorithms that can adapt and learn from data. And there is three main types of machine learning, which is unsupervised learning, supervised learning, and reinforcement learning. So today we will talk about supervised learning. And supervised learning is a type of the learning when you provide data with labels, with what is called golden standards. So if you put some features, you say what they describe. I think it's better to see it visually. So, for example, if we want to make our learning model, which distinguishes between apples and cupcakes, in our data, we label all apples as apples and cupcakes as cupcakes. And after the machine learning model learns this, all new cupcakes or apples, our model will be able to understand what they are. But before that, we need to show like 1,000 apples and 1,000 of cupcakes. And in supervised learning, there is two main tasks, which are classification and regression. They're quite similar. So classification, when we predict a class, so for example, cupcake and apple, it can be possible to have multiple classes: cupcake, apple, and bananas. So it's not limited to two. But there is no big difference between multi-class and two classes. So, and regression is for estimating price, for example. So you have a price of product changing over time, and you want to get to predict the price. So that's for time series analysis. Today we will talk mostly about classification. So the next type is unsupervised learning, and it's like opposite to supervised learning. When we don't have any labels, we don't provide any truths to machine learning model. We just provide data and let the model learn from the data. So it would look like this. For example, we have 1,000 documents, and we run it through some machine learning model, and we want those documents to be grouped into clusters. So the model would come up with such separation, and usually the workflow would look like that. You as a human, you review what are those groups meaningful, maybe join some groups, and then you have a final result. So that's very often used for exploring data set, and it's also in real life very common tasks, because not all data is labeled, and we need to know the unsupervised. But there is no way that we can teach everything in one presentation. So today we are focusing only on supervised. But
There's also reinforcement learning, which reinforcement learning, it's, I think you could say it's making decisions sequentially. So in you could say that if you have a model like similar to supervision learning, where you have actually the output which one predict cupcake or not cupcake, in reinforcement learning, you just say what outcome you want, and it's the job of the algorithm to figure out how it reaches that particular outcome. You may know one big example, which some of you know, is AlphaGo, which is a AI algorithm which is trained through deep reinforcement learning, which it has beaten the world champion in Go. And would be a good example. It's like, I want to win the game. Here are the rules. You can do anything, but you have to win. So there's a sequence of decisions which the algorithm which have to make, and then afterwards he will tell you, after a lot of decisions, he then knows if he did good or bad. So it's a bit more different in that case. And yeah, here's another example, one more particular. It's you would have some agent, which in this case could be a mouse or your robot or whatever, and it can take actions in an environment. So moving around the maze in this case, and he will get then a reward once he reaches the cheese. And he also, every time he takes an action, the environment changes. So his position, for example, in the maze changes. And this is a way this is how reinforcement works in a nutshell. But of course, this is definitely a subject which you can talk years about. And for data science in general, you don't do too much reinforcement learning, if at all. So I hope you've got AHA slides opened. As mentioned, if you just came now, the link is ahaslides.com/week4. Let me write it on the chat so you can join now. Okay, so now we're gonna back to the next thing, and we're gonna, why I want you to join AHA Slides is because we have a game show. Let me bring that music up. That's nice music for the course.
Because learning must be fun, and what's better than the games?
So, Bogdan, can you explain the rules?
So so I think everybody is familiar with this guessing game. So me and Adrian, we have a person in mind, and you need to ask us questions that we can answer yes, no, and sometimes maybe like kinda, and you need to guess this person. And how it will go, we will put a Q&A now. So you should, as audience, cooperate, vote for best questions, because it's or either all of you win or us, me and Adrian win, because you have a limited amount of questions. I think we will keep it under 15. And yes, that's I think basically it.
Oops.
So we have a, we have a person.
We have technical issues. We have technical issues now.
Please stand by.
The screen might be black, I think.
For me on stream, it's alright.
Yes. So currently, what we're experiencing is some issue with the laptop. It will be fixed any second now.
Okay, so yeah.
But
so
people can put their questions.
In this time, people put your questions and let people vote for it. And and then we will start answering the question.
And these has to be questions which can be answered with yes or no.
Yes.
Okay. So let's I think we can start.
Yeah.
Okay, 1 second. Okay, so let's start. So the first one, Julian, is it a real person? Yes.
Is this person alive? Yes.
Yes. Okay, next question is the person gender female? Yes.
Yeah. So that was already 3 questions. So yeah, this is a repeat, so we don't need to.
Yeah. You can let people. You have to upvote, because if there's only 1 like per question, we're not gonna answer it. So you have to also vote for other people.
Okay, famous person.
Wait. Okay, so next we have to wait until people now start liking. Yeah. Okay, so it's now actually another question. So the next one, I think, is this one. Is the person European? Yes.
Yes.
or no, or
Or yeah, it depends on definition of Europe, let's say.
okay, that's a hint, guys.
Yeah, it should give the better understanding. It's kinda.
Okay. Okay, we give
Okay.
2 more seconds so people can still upvote and this
Yeah.
devote. Okay. Next one is.
Is this
Oops.
person a scientist?
Oh, oops! I answered the question. Is the person a scientist? And it is no.
No.
Definitely not.
Yes.
Okay, good. So now we wait a bit again.
Yeah.
So we've got 7 questions answered, and you've got 8 to go.
Yeah, I think there is some duplicates in answers, so it's actually, let me check. 1, 2, 3, 3, 4, 5. We actually answered 5 questions.
Okay, 5. Okay, fine. Okay, let's answer another question. Is the person a politician?
Kinda.
Kinda. So
Kinda.
depends how you see it.
Yeah. Yeah.
Okay, we wait again. And they're getting close. They're getting close.
Famous person? Yes.
Okay, let me pin it. Mark it. Okay. Is the person older than 50?
Yes.
Yes, the person is over 50. Okay. Let's wait several minutes. I like the
Bogdan?
second. Is it Bogdan? Okay, people are voting it, so we have to answer this. Is it Bogdan? Is it you, Bogdan?
No, it's not me.
Ah.
I think you missed the question. There was a question: is the person older than 50 years? You clicked answer. Yes, the person
Yes,
is older
so-
than 50
So
years.
yeah. So the person is older than 50 years old, okay?
Yeah.
So Bogdan is not over 50.
Yeah.
He's halfway there at least.
Yeah. I'm not even halfway there, so please don't make me old.
Okay, let's answer the next one.
Is the person an actor? No, it's not an actor. And not even an actress.
Okay, we wait a bit.
Yeah. Does this person eat avocado? Like, probably? Who knows?
Probably. Okay, next serious question.
Is she from UK? Yes.
Yes, she is. Okay. Okay, and I think.
Yes, we have a winner. It's Queen Elizabeth.
So congratulations, good job.
So so why, like, so people still had a lot of room to ask questions, and and the reason why we played this game is actually that's the concept that we will explore today, which is decision trees. So Adrian, please take it further to decision trees.
Thank you, Bogdan. So what we did here is questions, right? Which can be answered through yes or no. And if you build the sequence of questions we built, you can build something like a decision tree, which is exactly like this. So you ask, like, is the person female? Yes. Oh, okay. Here I messed up the true and false here. She's female. Is she queen? Yes, Elizabeth. So this is how a decision tree may look like. Let's go for another example. So let's go to a problem which is, closer to my heart, because last week my feelings got hurt. You told me that I'm eating too much avocado and I will never afford a house. So let's talk about avocados. So if I would make a decision tree, if a person eats avocado, we could ask, is the person millennial? And if the person it is, then yes, it's avocado. And if the person is not millennial, then no. Let's go to find one more example. Let's because I want to buy real estate, Bogdan. I really want to get real estate. But I heard, like, if you are a millennial, you automatically don't own real estate. So I guess that's a no. But if I'm not a millennial and I have an income over 50,000 euros, then I could afford a house then. Okay, so now we know the idea of decision tree. How do you build a decision tree from this? Because like we are data scientists, we don't have we don't have this fancy plot. How can we make it from this data here, right? We have a data set where we have these features. We have millennial, if the person millennial, yes or no. The income, if it's over 50k or not. If the person eats avocado. And finally, if the person owns real estate or not. Well, first you have to decide what do you want to predict. And in this case, Bogdan, I want to predict if I can ever own real estate as a millennial. So I guess that should be my output. We also say this in machine learning target variable. And how to going to predict this? Well, based on the other data we have. So the rest, like if I'm a millennial, if I have income over 50k, if I eat avocado, right? These are my input. So I want to build a decision tree which makes questions from these three features and predict if I will own real estate or not. How are we going to do this? Well, first we have to determine who's the root of the decision tree. Which feature are we going to put? Are we going to put is the person millennial, or should we put first the income question, or should we put maybe the avocados first as a question? Which feature should we put as the king or queen of this monarchy? And for this, I'm going to ask your opinion, and then we're going to calculate to see who got it right. So I'm going to question you, which of the three features do you think is going to be the king or queen of this decision tree? If you just joined, don't forget, go to ahaslides.com/week3 as written in the top
Week
here.
4.
Week 4, sorry. I'm living in the past. Okay, so I think there's a clear majority that most people say that if the income over 50k is will be the king of this decision tree. Well, keep that in mind, and let's see at the end if you're right or not. So to do this, to determine the king or queen of this decision tree, we have to identify which feature separates the data the best. So let's do one feature at a time to get better understand this, how we can do this. So here we have the column millennial, and we have the column owns real estate. And what I did here is I want to build a decision tree for this feature. And I want to see how many millennials actually own real estate and how many not millennials own real estate. Because this actually tells me how good this feature separates the data. And what we're going to do, we're going to go through every line of in your data, and we do the following. So for the first row, we say this is not a millennial, and this non-millennial doesn't own real estate. So what we do, we go to our decision tree, we go to millennial, we go to no, and then increase the counter to 1, which the person doesn't own real estate. Let's go with the second row. This person is millennial and owns real estate. So we go to millennial, yes, and increase the counter for millennial, that the person owns real estate to yes. Third, if the person is a millennial and doesn't own real estate, we increase the counter. And we do it so on, so on, so on, so on, until we went through all our data. And at first glance, we can see it separates the data quite well. We can see that most millennials don't own real estate and most non-millennials own real estate, but it doesn't separate the data perfectly. When I mean separate the data perfectly, it doesn't tell me this person owns real estate, this person doesn't own real estate, right? There's some confusion here. So it's not bad, but not perfect. In ideal world, we would have something like this. So this is what we've got, but ideally we would have a clear separation between the feature where we say, okay, here in the left side, we have the people who own real estate, and on the other side, we have people who do not own real estate. So you don't have to be perfect, right? To understand how this entry works, we're gonna go for a famous quote. You don't have to be perfect. You have to be just better than your competition. And I think Queen Elizabeth II actually said it herself. I cannot confirm nor deny if it's true. So you just have to find a feature which is the best. It doesn't have to separate the data perfectly to be the king of this monarchy. So what we're gonna do is do the same thing as we did for the millennial, where we're gonna see how many people own real estate and how many don't own real estate. Don't forget, real estate is if the person owns real estate is the feature we want to predict. So that's why we're doing this. But how do we determine which feature is better or not? None of these features are perfect. So a machine learning term for this is impure. So if none of your features separates the data perfectly, then these features are considered impure. And we can measure this thing. How? With the Gini impurity. With Gini impurity, we can calculate this. So the formula is very simple. It is 1 minus the probability of yes, so that person owning real estate squared, minus the probability of no squared. Probability of the person not owning real estate. Now, I want you to write this formula down. That's why I asked you to need your pen and paper, because we're gonna need it for our upcoming exercise. Now, we're gonna show you how we can use this formula to calculate the impurity in this entry. So let's go back to our millennial decision tree. We've got here on the left people who own real estate, and the left who don't. Here we have the people who are millennials, and we want to calculate the impurity of this of the remaining data. So we're going to calculate the impurity of the left leaf of this decision tree. So we remember that our formula is 1 minus probability of yes minus the probability of no, both squared. So this is equal as the following. What is the probability of yes? So the probability of yes, if you remember from the first week, is the expected outcomes or desired outcomes, which is 34, divided by all possible outcomes. And in this case, all possible outcomes are the sum between of yes and no. So that's why we write 34 divided by 34 plus 125 squared. And what is the probability of no? Well, in this case, the desired outcome is 125, and the total amount of outcomes is again the same sum, 34 plus 125. And this will give us a score of 0.336. So what this value mean? So if you have a data which splits the data perfectly, then the gene impurity would be 0. And if it's very impure, then it would go upwards. So we're gonna do an exercise now, and we calculate the gene impurity for the left side. Your task is now to calculate the gene impurity for the right leaf. So this one here. We're gonna give you 1 minute and 10 seconds to solve this exercise. If you don't have the formula, here's it one more time. It's 1 minus the probability of yes minus the probability of no. Each of them are squared. Good luck. Your time starts right now. Okay. Now it's time you to put your submission on AHA slides. So join the quiz, pick your favorite emoji, and it's time to vote. So let's see. I see familiar faces, loyal people from the course. Okay, I guess we're gonna start the quiz right now. So the question was, what is the Gini purity of the right leaf? Let's see how well you did, guys. Put your answers in AHA slides. Okay, time's up. And excellent, great job, everybody. You're amazing. Like, you are perfect. You are ready for your job very soon. So let's check the leaderboard. And we've got some new person who's leading, Massine, followed by Zu, Bernard, Olivier, Lucas, Stefan, and JF. Okay, so if you didn't got the answer, here's the answer. So it's 1 minus the desired probability of yes, which is 105 divided by the sum, so 39 plus 105, minus probability of no, which is 39 divided with the sum. And this gives you the result of 0.395. Okay. So we calculated now the Gini impurity for the left leaf and the right leaf. However, we didn't calculate the Gini impurity for millennial feature. How do you calculate that? Well, it's quite simple. The Gini impurity for millennial, so for a feature, is the weighted average of Gini impurities for the nodes. So you would calculate the weighted average of these two Gini impurities. More precisely, you will write the following. You would write the total values which go on the left node, which is 159. Why 159? This is 39 plus 125. That's why. And divided by the total amount of data. So in their case, this is the sum of could be the number of rows in our data set, or you can sum all these values here together. So in our case, this is 159 plus 144. Why 144? Because they are on 144 data points in the right. And this value, so this probability, we then multiply with the Gini score of that leaf. And then we do the same for the right side. But in this case, we have here 144 divided by the sum. And with the Gini score for the other side. And this gives you the Gini score for the whole feature. And these steps... Okay. Why do I have here a quiz? I forgot. Ignore. Yeah, I that's something which didn't. Oh, it crashed again. AHA slides, no problem. We are going for technical break again. Not a lucky day. Maybe because of the heat outside.
Yeah.
While I'm at it, I can also fix the quiz. Yeah, I'll take this opportunity. You can see behind the scenes how we solve data science things. Okay. Now it's working again. So we can see here, we calculated then the Gini impurity for all features. And we have here all the features, 0.36, 0.3864, and so on. And now the question is, which feature should be then the root of the tree. We know how to calculate impurity. Now, the question is, which feature should deserve that place? And time's up. Okay, so most of you got it correct. It's the income, because the lowest value is important, right? The lower the value, the more pure the feature is. And wow, Massine is leading the leaderboard. And we also see our old faces like Max and Arno. Okay, so so that's how we do it. We put the feature which has the lowest gene impurity on the top, and in this case is income. And income now, the feature income is the king or queen of this monarchy. However, we have other features we can still use to reduce the impurity in our data, therefore making better predictions. So this is income. This is the decision tree for the income, and we see on the yes side we don't have a pure separation between of the people who own real estate or not. So the task now is to determine which feature could we use to further improve this impurity. So in other words, which feature can we use to separate the split even more? And here I'm writing, like, so it's easier to read. I'm gonna write here the remaining people left after this split. So here we see 37 people who don't own real estate and 127 people who don't. So how are we going to do this? Well, to determine which feature is the best, separates the rest of data, we calculate the gene impurity for the remaining of the data. So we do the same thing as before. We take the remaining data points, we split them by our feature again, and we can see here, some values, and then we calculate the Gini score again. And in this case, we can see the avocado separates the data the best, and then we would use then this feature for that part of the tree, like this. And that's how you build decision trees. You just repeat this process all over again until you have no more features left, or your Gini impurity is 0. Why should you stop when your Gini impurity is 0? Well, if you already separated the data perfectly, there's no need for additional features. So that's how it works. But what about numerical features? Let's say we looked only at with yes or no, when you have only 0 and 1. How we do with this? Well, it's quite similar. Step 1, you sort the data ascending. So in our case, the numerical feature lowest value is 1000. So we sort them by that, and then downwards where the last value is the highest. Step 2, we calculate the mean between adjacent rows. So in this case, we have 1000, 1500. The mean between these two is 1250. For the next two rows, 1500, 2000, the average is 1750. And we repeat this for all of the remaining of the data. And step 3 is we calculate for every mean value the Gini impurity. So that means we would take first this value here, 1250, and we would create a decision tree, a decision node, where you would say, okay, if the debt is under 1250, is the debt under 150? If yes, then it goes on the yes pile. If no, it goes in no pile, and you calculate the Gini impurity from this one. So in this case, in this particular example, the Gini impurity is 0.367. And you would do this, repeat for all of them until you find the feature which has the lowest Gini impurity. And in this case, you would 1750 has the lowest one, so that feature you would take, that number you would take for that particular feature. Okay. So now we learned about the theory. Let's do it in practice. And as again, we're going to use Google Colab. And you just go on Google Colab. We go on the GitHub tab, search AI grads, and select week 3. Week 4. I don't know why I have this week 3 in my head. So, in case you forgot, you just go on Google, write Google Colab, and then you enter Google Colab. You then go to GitHub and write here AI grads, and then you enter week 4. If you successfully did this, oh, where is week 4? Not here. If you successfully did this, press the heart button on AHA Slides to tell us that it worked out for you. So far, only 6 people got it, so put it in. And if you have any problems, just write quickly in the chat. Maybe we can help you out.
Oh. Yeah, really, Colab is spelled with one L.
Thank you for...
I never noticed.
Okay. 21, 20. Okay. Most of you got it, I think. So, I think everybody is in. Also, please, just go on AHA Slides, tell us it worked out for you. I'm going to do it one more time just out of the courtesy, and then we're going to start. So, you go on Google. Hopefully you have a Google account, but I think by now, because you're week 4, you already have this. So, Google Colab. And it's with one L. Oops, again, mistake from my side. And we go then to GitHub. So, this page should appear. Here, then you type in AI grads. Press enter. And then select week 4. Simple. Okay. So, Bogdan, I really want to know if I can buy a house. I'm trying to stop eating avocados, and I will try to buy a house now. I want to get in the real estate game, but I'm not sure if I'm gonna get a loan. So I think it's a good idea for me to make a model which can predict if I will get either a loan. What do you think? Is that a good idea?
Yeah, that's actually very common use of machine learning in banking to estimate people credit score. So your idea is very valid.
And this is the data set we're gonna use today. Again, this is a data set which is available on Kaggle. So what I would like you to do is to press on connect and start the notebook. And today we're gonna use some libraries. And the first line of code will install a library called rfpimp, which is, I think, random forest for pimps or something like that.
It's a random forest permutational importance, but also for pimps.
And we're gonna run this. You will get the warning. You just say run anyway. And this will install this package we're gonna use later. After that, we're gonna download the dataset. So again, very simple. And here, it looks scary. We have a lot of libraries here, but don't worry. Even though these are a lot of imports, lot of the things we're going to do today they're like one line of code, so it should be very easy to program. So don't get intimidated by the amount of libraries we've got here today. Run that. We're going to also load the random forest permutation importance. And then we're going to run the data frame. So loading the data. And if everything went well, then if you run the next line of code with the df.head, then you should see the data set. So let's go through the data. So we've got the loan ID, which is just the loan application ID of the person. We've got gender of the person, which is male or female. If the person is married, yes or no. Dependence is how many people are financially dependent by that person. So for example, your children, or maybe you're taking care of your parents, whatever, who are legally or dependent by you. Education, if the person is self-employed, yes or not. The income of the person who applies, and also if you're co-applying with someone, also that person's income. Then the loan amount, how big is the loan, and then we have the loan amount term. So how many days or do you have to repay the loan? Then you've got the credit score, credit history, and it's a binary variable, 0 or 1, which refers to if you ever had a credit in the past or not. So 0 means you never had a credit, and 1 you had a credit and you paid it back. And then we got the property area, is the region where you live, if it's urban or rural. And finally, if your loan got accepted or not. So yes or no. So this is the data we're going to work today. Now, the data is quite small. It has around 614 rows. And they're all unique. So every row is a unique application. There's no duplicates or anything like that. Now, we're not going to focus too much on data visualization and exploring the data too much, because as we already covered this by last week, and based on the assignments you did, guys, I think it's just waste of time for you. So we're going to go quickly through the data. One thing is to note is that most applications are accepted in this data set. And there's no like any obvious correlation between the loan and the gender. And also there are more male applications for the loans than female. So it's a really disbalance, as there are like around 100 cases for female and around 400-500 cases for male. So these are like some important things you have to keep in mind. Okay, so we have one quiz now, and this is something we did in the second week, and this is quite asking how many missing rows there are, because you have some missing values here. So for our next quiz, I'm gonna ask you, how many missing values does the column gender have? Oh, I gave you not enough time, so it's only 50 seconds. That's maybe a bit unfair. So determine how many missing values are there for the column gender, and we give you 30 seconds for that. Okay, now you can put your answers on AHA slides, and let's see. So the question was, how many missing values does the column gender have? Okay, time's up. And some of you got it right. So some of you say it's 0, and we're gonna show that it's 13. So no problem if you got it wrong. It's no problem. Maybe, some commands you don't remember, and that's fine. Most of the time we also don't remember them. So the solution, one of the solutions to check this is write df.isNull, and then we write .sum. And this shows us all the missing data in all data sets. So in this case, on the gender column, we have 13. But we also have other features which have missing values. Now, on the second week, what we did, we just deleted all missing values. But for now, I'm going to show you some techniques where how you can do it better as in our case. Because we have only 600 data points. For machine learning, that's for most of the time not enough. So you want to save every data point you can. And if you recall from last time, there's some other ways to deal with missing values. Now, one of the ways to deal with this is to replace the missing value with the most frequent value, or maybe the average, maybe the median, right? Some value which you could fill instead of the missing value. In our case, we're gonna showcase two ways to do this. The first way is with the most frequent value, and that's something you would use if you have ordinal or nominal data. So what I've provided here in this code is the list of columns which have missing values and are ordinal or nominal. And to solve this issue, like replacing the most frequent value, we're gonna use a function from scikit-learn called simple imputer. Simple imputer is an algorithm which imputes missing data, and what you have to do is provide two things. First, you have to tell it how your missing data looks like. In our case, it's a none value, so we write numpy.none. This is a data format which represents missing values, but it could be some other value. Maybe in your data it's like written -1 or some or particular string. So you just put how your missing values are defined there. And secondly, you would define the strategy you would like to use for filling those missing values. And here you can put like mean, median, and some other techniques. In our case, we're going to use the most frequent value. And this is an object which we're going to save in a variable, and we call this one impute missing. Now, we just created the model which can impute missing data. Now we have to use it. To use it, we're gonna replace our old columns which have missing values with the new ones which have imputed values in those. So the way it works, we will call impute missing, and we will call a function called filTransform. And here we pass our data frame with the columns which have those missing values. And this will then, what fit means, the fit part of the algorithm basically identifies which are the most frequent values in your dataset, and then transform then replaces those missing values with the most frequent value. So if I run this, I would check on I could recalculate the missing values, and we can see here that they're 0. And here we replaces those with the most frequent value. For example, in gender, the most frequent value is male, so we would replace the most frequent values with the value male. Okay, let's go. But we don't have only nominal and ordinal data. We have also missing values for numerical data. In our case, lone. And in this case, we can use the same function. So we write impute missing, simple imputer. We define how our missing value is defined, and we define the strategy with mean. So in this case, we want to replace missing values with the mean value. And again, it's almost the same code as before. and you just define what columns are your missing value in, and then replace it with replace your old one. And if you really check again the missing values, we would have 0 overall. And perfect. Now, before we can train our decision tree, there's one more step. And after we go through this, we're gonna have a break. So the break is very close. Now, we saw decision trees can deal with values like 0 and 1 and numerical data, but categorical data, but it doesn't understand strings like male, female. Those are not understandable for an algorithm. So you have to transform them to 0 and 1s. Furthermore, if you have columns which have multiple values, let's say in education, where you have multiple types of education, then you have a problem, because those are going to be represented as numbers 0, 1, 2, 3, but those are not numerical values, those are categorical values. So what you have to do is something called one-hot encoding. So one-hot encoding works like this. Let's say we have a feature called color. And here we have 3 colors: red, yellow, green, and yellow. How one-hot encoding works is that you create a column for every feature you have, every unique value you have in that column. And we're gonna then do binary values for every column. So it's 0 and 1. And this solves the problem. So let's go through the example. We have red. Well, if the first row is red, then we write here 1, and all the other values is 0. Second row is red. Again, first value is 1, so it's true, and every else is 0. Then we have yellow, and in this case, red is 0, yellow is 1, green is 0, and so on. However, we don't need all 3 of them. Actually, if we would just remove the first column, red, this also works. Let me show you how. Here we have red, and red can be represented as not green and not yellow. So you don't need all 3 of them. You can just, if you have 3 unique values, then you need only 2 columns to represent your data. More specifically, if you have k features, you need k minus 1 columns. So this is a technique what you will use very often, and it's quite easy to do with pandas and scikit-learn. So first, we're gonna have to have our categorical data. Here I provided already a list of categorical data. And now we're gonna do something. We're gonna convert our categorical data to a data type called category. So this data type, so what this code does is we're going through every value in this array. So first we the first value will be then gender, then after married, dependent, and we go through. What we're gonna do is we're gonna make the data frame as the data type category. And category has some nice properties which we're gonna use in a moment. So we're gonna run this code. And one thing I want to do before I'm gonna show, I want to remove the loan ID column, because for a machine learning algorithm like random forest, we don't really care which loan application it is. So we're gonna remove it. And to get the one-hot encoding, we write the following. We write df equal pd, so pandas get dummies, and here we pass as a variable the data frame, and we write here drop first true. So what drop first true does, it removes the first column of that feature. So as you remember with the example previously where we had red, yellow, green, we just remove the red one because we don't need the extra one. If I would run this, and look at the data frame, you will see lot of columns. And we can go through them so you understand what happens. So for example, with gender, we have here gender male, and we don't have another column called gender female. So as you can see, for every feature which is categorical, we got the column name and then underscore the value of that column. And in this case, because we have two genders and we wrote this command drop first true, we only have gender female removed, and we only have the male one. Same with married, right? We are only married, yes. For dependents, we have 4 unique values. We have dependent 0, dependent 1, dependent 2, and dependent 3 plus. So in this case, we removed dependent 0, and we kept dependents 1, 2, and 3. And we did this for all the columns in our data. What I want to do is the last column. I don't really like how it's called. It's called loan status underscore y. I'm going to rename it just to loan. And for this, for this line of code, it does exactly this. What I'm doing here is I'm taking all the columns names except the last one. That's why this command here basically gives me all the columns with except the last one. And then I replace the last column with the name loan. So if I run this and check the data frame again, all the column names should be the same except the last one. So here we can see loan. Okay, we're almost there. One more step before we can go to our algorithm. So we have to split our data. As you recall in the beginning, we had determined what is our input data and what is our output data. Our output data should be our target variable. So the value we want to predict. What is that? Well, in our case, it is the last column, which is a loan. So here we can write the following command. Maybe I can rewrite this so it's just more readable. Like this. And what I wrote here is x df, and here I'm getting all the columns except the last one. So let me show you what this command does more in. Let me break it down for you. So if I write df.columns, I get all the columns, and if I write, you can see here all the columns also low. And if I write here this, so everything -1, which means go backwards in the list and accept the last one, you will get the same except the loan. Okay. And what I'm doing here is it's standard convention to write your input as x and your y as your output. So we're gonna do this. And if we would check x, we can see that x is all the data except the loan. As you can see here, all the columns except the loan. And if we check y, we get only the loan. So if they got accepted or not. And finally, we prepared the data, we dealt with missing values. Now we can do decision trees. And what we're going to show you, code-wise, can be applied for almost all the machine learning algorithms implemented in scikit-learn. And we're going to see more examples of this with random forests, which Bogdan will present later. So it's simple. Step 1, you define your model. In our case, we imported the library, the algorithm decision tree. And in our case, we have a decision tree classifier because we want to classify if you get the credit or a loan or not. And there are a lot of other parameters you can change here. So for example, you can define the criteria how the decision tree is split by. In our case, we learned today about Gini. So here you can use criterion Gini, which is default. But there's also other ways to split your data by, for example, based on entropy and so on. And you can play with the parameters here. You can say, okay, how big my tree should be, how wide it should be. There are a lot of properties which you can change here about your tree. For now, we're going to just use the default variables. And we run this. The second step is to fit your data. You have data, you have to do the splitting. You have to calculate your genies, right? You have to determine who's your king of your monarchy, of your tree, right? All that thing we explored previously. It's simple. You write model.fit, and you always pass two variables. The first variable is your input. The second variable you pass is your output. Simple. It's simple as that. You run this code, and then we can actually see how the tree looks like. So here, this code here just shows a visual representation of the decision tree. So if I run this, it takes a while. But what we can see here, after fitting, it says what parameters were used for training. So it just gives you, notifies you. And after the model is trained, we get this decision tree. Now we're not going to look into it now, but these are all the features we have, and we can see how this decision tree may look like. And we're done. You know now data science. Congratulations. You have mastered the art of machine learning. It's simple as that.
But Adrian, like, how good is your model? Can you tell us that?
Oh, doesn't matter. I fit my model. I train machine learning algorithms, right? That's
yeah. So you have a trained model, but you have no idea how good it is. And we will talk about it after the break. So after the break, we will learn how to evaluate models and to know if they are good or not. So 10 minutes break.
Yes, 10 minutes break. And yes, we'll see you in 10 minutes. Hello, everybody. I hope you had a great break. You're feeling energized and you're ready to hear the truth about machine learning and evaluating decision trees. So, Bogdan, what you were telling me that I did a bad job with my model.
Yeah. So like you didn't do bad job, you just did a half job because you just trained the model but didn't do any. And what we're gonna do is we will learn how to evaluate uh, models correctly. And yeah, so first of all, to evaluate the model, you need to have a training set and a test set. So training is the data that is used for training the model, the fitting the model, and testing should be independent data that you don't touch, and then you test your model, a trained model on that data set. And normally you can split your data 80% for training, 20% testing. The percentage may differ and use it. So it looks the schematic of that very simple. So as I said, you split data into train and test. You do model training, and then you provide a trained model with the test input, and you evaluate the output from the model and the test values and compare them how similar they are. So we will look today on the example of classification, binary classifications, or when we have 1 and 0 as possible outputs. So when we have 1 and 0 as outputs, there's four different cases. First case is when you predict 1 and test is 0. This is called false positive because you said it's positive, but it's false. Second case is you predict 1 and the test label or correct answer is 1. It's true positive. Next one is 0. Your prediction is 0. The truth is 1. It's called false negative. And the last case is 0, 0, which are called a true negative. So these four values, they form a confusion matrix, which is the core for evaluating the core evaluating classification model. And from here you can derive a lot of metrics. And one easy example to understand it is with the case of pregnancy. So we can see that here first it's a true positive because the woman is visibly pregnant and doctor said she is pregnant. And then we have a man, doctor saying to the old guy that he is pregnant, and that's a false positive because, well, he is not pregnant and probably cannot be. Then there is a false negative when the woman is pregnant, but doctor saying she's not pregnant, and the true negative when the doctor says to the guy, "You're not pregnant." So that's a nice way to remember it, but you can always for me it's easier to remember numbers, but for different people it's work differently. But it's very important for classification to understand confusion metric, because from confusion metric you derive all the metrics for evaluation. And the first metric is called accuracy. So what accuracy is the sum of our true correct prediction divided by the sum of overall predictions. So I would suggest you firstly copy this formula because we will have some quizzes later, and if you want to get the first place, you will need to do the calculation. Or if you are sure in your memory, you can just memorize. So that's a sum of all correct predictions divided by by all possible predictions. So let's look how it would look visually. So let's say we have the model that need to put yellow squares into our circle, and blue circles should be outside of result circle. So yellow circle that is in yellow square that is inside of our result circle is true positive. The blue circle that is inside the result circle is false positive. The blue circles that are outside the result circle is true negative. And the yellow square that is outside is false negative. In this case, we don't have it because this is the example of high accuracy. So that's how the model with high accuracy would look like. And if you build the confusion matrix, it would look like this. So we had 9 true positives, 1 false positive, 0 false negatives, and 8 true negatives. So formula for accuracy is very easy to remember because you focus on the diagonal. So you can say that the model is accurate when the diagonal values are high. So that's how to remember the model. So low accuracy would look like this. When you, in the side of our result circle, you have a mix of yellow squares and blue circles, and a lot of squares outside the result circle. So that's an example of low accuracy. So even without calculating exact number, if you look on a correlation matrix, confusion matrix, if you look on the confusion matrix, we can see that you see the diagonal values are lower than other values. So it means that the accuracy is quite low. But accuracy as a measurement have one very weak point, and that in a case where you have imbalanced data. So if you, especially if the imbalance is really huge. So for example, like here we have only yellow squares and 1 blue circle. And the danger of it is that most of the model, when presented with such distribution of data, they will never find that blue circle. They will always put everything into your result. And accuracy will never detect it, because here, if accuracy would be very high, there's only 1 false positive. So that's why we need other measurements too. So one of such measures is precision. Precision basically says how much of your true positives are really true. So you take your amount of true positives and divide it by sum of true positives and false positives. So exactly the true amount to total amount of what you said is true. So if we look on a visual representation, we see this is example of high precision, because we have 4 yellow squares inside and only 1 blue circle. So with precision, you only focus what is inside the result circle. So you don't focus what is outside, only on what is inside. And in confusion matrix, it means that you are focusing on the first row of the matrix. So on the 4 true positives and 1 false positive. So you just look on the first. So you have 4 correct and 1 wrong. So the precision would be 4 divided by 5. So we don't really even look on other numbers. So that's a precision. First row of confusion matrix. So low precision would mean that in your result, you same as in accuracy, is that your result have a lot of mix values inside your circle. So here, we have four true positives and 5. Was it 4 or 5? Yeah, I think.
Four.
Yeah, it's 4.
So it's
Yeah, but
50% precision.
yes. Yeah, I just think there's 5 in a picture, but in the confusion, but doesn't matter. Yeah.
Yep.
So let's quickly move to the next one. The problem of precision. So if you become very you really want to have very high precision, what can happen that your model will just select only one. It will miss 99%, but will select only 1% where it's completely sure, because in this case the precision would be 100%, because there is no blue circles inside the results. So we missed a lot of data, a lot of results, and that's again a big problem for this. And so to deal with that, there is another metric called recall, which is true positive divided on true positive plus false negative. So it otherwise you can interpret it how many of the correct values we get, how many we missed or didn't miss, because what it wants to see is how many of those yellow squares ended up in result circles. So here we have a high recall because only one circle is outside, or only one square is outside the circle. And recall doesn't look on blue circles inside your result circle. It just really checks how many of those yellow squares get into result. So in the confusion matrix, it would mean that we focus on the first column. So precision is on the first row, and recall is on the first column. So we sum the first column, and so we took the true positive and divided by the sum of the first column.
So 8 divided by 9.
Yeah. So here is the case where the precision is 100%, but the recall is very low, because recall is focusing on how many squares are inside of the circle, and in this case it's very, very low. So you see that you can, so now you can see that it's very low. It's opposite of what was before. Yeah, so we have only one true positive and a lot of false negatives. So a problem of recall is that if you put all the data inside the result, you will end up with perfect recall, because you didn't lose any yellow squares. They're all in the result, but the problem, you took everything there. So if you look on the problem cases of precision and recall together, we can see that they can balance each other out. So when you have problem with precision, you can look on recall and vice versa, because they are focusing precision is focusing what is inside the circle, and recall is focusing what is outside the circle. So if you combine these two measurements, you will get a measurement which can describe your model even better than accuracy. And this matrix F1 score, which is harmonical mean between precision and recall. So you take precision recall, you multiply it, divide it by sum, and multiply it by 2. So that's a harmonical mean. And F1 score is the most common, and it's used in a lot of scientific literature and also in workplace. So that's very important. And generally, these 4 are the most common. There's of course a lot of different other metrics, but this is, I would say, like 90% of use cases. And yeah, so let's get to exercises. So here's the confusion matrix. And in next quizzes you will have to calculate all the metrics that we just learned. So put the confusion matrix on the paper that you prepared, and for every metric you will have 1 minute to calculate it. So that's 15 true positive, 45 false positive, 35 false negatives, and 25 true negatives. So yeah, so let's go to the quizzes. So just a reminder on diagonal. Great. That's yeah. That's precision. No, because as the precision is in the first row. And there's enough time to Google, the formula again. So it, yeah, great. So people were paying attention. And recall, yeah. So recall is in the first column. Recall is wrong in quiz, maybe. Okay, we get a comment. That was the correct answer. Let me check, because maybe I forget how to count. Yeah. I'm sorry, but yes. Oopsie, yes. The correct answer is missing. You are right, people. I forget how division works, so bonus points to those people who didn't answer. Go. One person like has same level of math me. Yeah. I'm yeah. That's. I'm sorry, because I somehow managed to add 35 plus 15 equal to 7. That's yeah. No. We can. Oh, we can hear Adrian.
Oh, hello. Oh, okay. Shit. Oh shit. Yeah, what I was saying, guys, is like, please forgive us. We're doing mistakes. It's a lot of effort for
It was
this course.
intended. It was intended. I wanted to see who are really paying attention.
Yeah, that's actually true. So let's see
Yeah,
who
yeah.
really paid attention.
Yeah. So bonus point. We will remember it.
19 smart people. Okay.
Okay. So there won't. I thought there will be easy answer. Yes. There is. So here won't be answer. There is no correct answer for the next question again, because I calculated it based on my record. So put in a chat correct answer for F1 score.
Yeah, put in the chat. Let us hear you guys. And if you're actually extra smart, you can use the recall of Bogdan to calculate the incorrect correct answer to get your points.
Yeah.
So you can, you still have time to get some extra points from the quiz for free. Okay, let's see if some people manage to calculate the wrong. Wow! Wow! 5 people actually calculated it. Try to get the incorrect correct version. Oh,
Yeah,
amazing!
it was. Yeah. So again, thank you, people, for paying attention and not letting my mistakes slide around.
Amazing.
Amazing.
I'm impressed.
So we will add manually the answer points to people who wrote it in the chat.
So now we arrive to the final question of today, and we've got a new leader from today's course. Congratulations, Lucas, for finding our incorrect correct answers.
Yes, you are on the same level. We have like some mental connection between us.
Followed by Olivier, Arno, Max, OIQ, the D, and Massine, which is interesting because Massine, she or him, was leading the leaderboard and now slipped off at the end.
Yeah, probably because of the wrong answers.
Probably.
But that's life. Sometimes as one corrected leaderboard, we are email, of course. Yeah, stay subscribed to get the correct leader. Okay, let's get back as let's get back into yeah, let's get to the Google Colab and actually check so we can see how decision trees form for our data set of loans, and yeah, how correct, how well can we predict the loan decision. So first what we need to do is to make the train test split, and we will use a train test split function provided by scikit-learn library, and it does what it says it do. It splits your data into train and test data sets. So what you provide your x, your input data, your y, your output. You provide test size, meaning how many what percentage of your data you want, what proportion of your data you want to be in test. In this case, I choose to use 1/3, and random state is you fix the random seed, meaning that you will always have same output, because if you don't fix random, you will have a different output every time, and that's that's it's just for this purpose of training, so we know what answers we'll get when we show the code. Yeah, so we do split, and now
let's look how the data looks like. So if you look at Xtrain, we can see it has 411 rows, and if we go to Y-Train, we would get the same rows but for the loans. So we can see here again 411 but for loans. And if you look at the shape of the test, it should be a quarter of that. So of the old data set, so it should be like in this case 200 samples, as you can see here. So a third of that. Okay, so now we've got our data. What we're going to do now?
same what you did. We will train the model, but only on a trained data. So model, decision tree, classifier, and we fit it. Yeah. So it's really fast. And now we need a prediction from our model. So what we will use the test input, so input X, and we will use model to predict values. So when we do it, Y prediction, Y prediction would be a vector of 1 and zeros. So what we will do, we will compare our prediction to our test values, and we will calculate accuracy, precision, recall, and F1 score. So scikit has it already ready for you. So we will just run it here. So we have 69 accuracy score, 74 precision, 79 recall, and F1 77. So I would say it's not a bad starters, and it seems good. So what you would say, maybe so the goal would be to get as high evaluation metrics as possible. So get to the one, as close to the one as possible. But do we want to get to have everything one? Is it a dream of data scientists to have everything one? I wouldn't say so, because it may be a dream, but it's a horror dream, because it means that our model overfitted our data. So what overfitting does is that our model, instead of generalizing, finding general picture, it just learned every data point, and becomes so complex that it learned noise and unimportant features. So that's what overfitting is. And it looks, if you look on pictures, it's much easier to understand. So yeah, so instead of getting general trend, we just join data points by line, and that's not what we want to have in our models. And to deal with that, we can use technique called k-fold cross validation. So k-fold cross validation is quite similar to what we did with train test split, but now we do it basically in a cycle. And we what we do, we take let's say so we say we make 10 steps now. In the first step, we select one part of data set. So let's imagine that this blue thing is our data, and and orange will be our validations. So it's part from that. So we will train on model training set and validate it on validation set, and we will calculate our accuracy. It will be 93% in this case, and so 93%. That's our first fold. On the second fold, we change our training set. We move it, to next part of data frame, and do same steps. And after we are done with all the steps, we calculate mean of all accuracy for all the steps, and we get our average and final accuracy for a model. And so again, how it would look like, it would get that on the first step we get this high value, on the second step we get like following values, and on the third step we get, and then after third step we just average, and we get nice good results. But this is the case of well fit model. And if we, now we can look how this will help us to detect over models that was with overfitting problem. So it can be that like your first step is really good, no problems, you really have high result. But when you do second fold, you get extremely low values. On the third step, you can get average values. And if you make more steps, more folds, it can be you have high, low values. So it means that variance of your model is of your results is very high. So sometimes you get 90%, sometimes you get 1, and it means that you have issue with overfitting, and you need to deal with that. There is different techniques, and there are some models that are resisting to overfitting, which like random forest is resisted to overfitting, and we will talk about it later. But before that, let's look how we can do it in with Python and scikit-learn library.
So now we've got here the model. Again, we define the model we want. In this case, we want a decision tree. And for this, again, there's a command in scikit-learn which does automatically k-fold validation for us. That means it takes the data, it splits this in the number of folds we want, and then train the model k times, so the amount of folds we have, and doing exactly what Bogdan previously did. This command is called cross validate, and it requires the model which we defined, which is decision tree. Input.
It's important that the model is not trained, it's just empty.
Yes, you just define what kind of model you want, input and output, and then CV stands for cross validation or k folds. In this case, it could be you can define how much you want. A standard is 5 or 10, but in this case we use 3 due to this is also very dependent on your data set. The bigger the data you have, the more steps you can do. And finally, you can also ask, this is optional, you can ask what based on what scorings we want. In our case, we want accuracy, precision, recall, and F1 score, so we just pass them these. These are optional. Standards is just accuracy. And if you run this, it trained the model, it does the cross validation, and then we can see the scores. So you want to mention anything about the scores?
Yeah, so what we can see is now, like, for each fault we get a nice score, and here we see that we have quite stable results. They, of course, they will differ from each other, but here variance is not high, and we can say is well fed. And we will look closer on that results a little bit later when we will compare it to random forest. So back to slide. So opposite of overfitting is underfitting. And underfitting is when your model cannot model your training data and cannot generalize for testing data. And it's usually because you don't have enough data, and it doesn't mean that, like, you don't have enough rows of data. It's maybe your features are so impure that cannot do anything with those features. So here again how it looks, how underfit, optimal, and overfit looks. So we see underfit just puts the line there, and optimal gets the general picture, and overfit just joins all the data points of this line. So now to forest. I already mentioned random forest few times here, and you may be wondering, what forest are we talking about? Are we talking about this forest or something more machine learning? And of course, about machine learning. And random forest, how the name is suggested, I think, is built on trees. So like a forest in a real life consists of trees, random forest consists of decision trees. The idea of this model is very simple. You have a bunch of decision trees, they make their predictions, and then you do majority voting on them. And basically, so here it's like six model said 1, 3 model said 0, the prediction is 1. And random forest show itself to be very effective model. It's used in a lot of cases, and it's very common to use it. I use it a lot, so it's not just learning, it's that you would use in real life.
Yeah.
And yep, Adrian.
Yes, and there's also a research paper, which talks about random forest being, I think it compares it to the Swiss knife of machine learning algorithms. So even though it may be not the best algorithm, it can definitely solve almost all problems, and it has been used in a lot of things. It's still state of the art in, like, for example, in certain fields in chemistry. It was used, for example, in the Microsoft Kinect, which was on the Xbox. It's a model which is even used in medical industry a lot, and also in certain financial industries also. So it's a very versatile algorithm. It's like, if you don't know what to do with your data, just run random forest. Most likely, it will work on it.
Yeah, and we already understand how decision tree works, so we will easily understand how random. So let's look into steps of how we. So first, we have our training data, and we divide it in bootstrap samples. And what are bootstrap samples? It's very fancy way of saying that sample data. So it means that we sample our data with replacement, and and it means that when we when we sample our data, we don't remove the values, we keep them. So it means that we can get same values few times. So that's what this means, drawing with replacement. Let's look better on a picture. So let's say we have this our initial data set 12 numbers, and we built our bootstrap samples of 5. And so it means I take 1. So in first case I take, then I take 10, and I take 3, and you see that 3 repeats itself. So it means that when I take 3 initial data set, I don't take it away, it's still there, and I can take it again. So it can be that our sample is just like bunch of same values. So we do this. So we do this bootstrap sample, and with them we train our decision trees. And the value of doing this comes from the fact that strength is in numbers. And the problem why decision tree cannot be used on its own, that it's a weak learner, and it's very sensitive to wrong data. So on the next slide we can see the representation of data. It's not next slide. Something. Maybe next slide. Oh yeah, this slide. Yeah, this slide. On this slide, we can see the representation of data. And let's say that our green data is the data that is correct, and our data, our decision tree can easily learn from it and easily generalize it. But red data is such data that completely ruins our tree, and tree cannot produce a good result if such data is introduced in this tree. And that's the, so as I said, that's the weakness of decision tree when it's on its own. But when we make a forest of such trees, we will have a lot of trees that have correct data. So if you look to the right, so we have like 9 samples, and 6 of those samples are correct, and 3 of them are wrong. So it means that that 3 of them will always produce bad results, but 6 of them will produce good results. And that's why we do a majority algorithms for the decision trees. So when after we trained all those decision trees, we get the results from them, and we just do majority voting, and that's our result, our label.
Yeah, it seems like some slides
Yeah.
are.
Yeah. There was some
Yeah.
permutation.
Yeah, but
with
first,
our slides.
yeah.
Yeah. So that's how it how the random forest process of training random forest look like. And let's go to the slide, to the Google Colab, so we can see how you do it with the code.
Okay, so as Bogdan mentioned, we want to use random forest, and it's very simple. It's always the same. You just take the algorithm you need in scikit-learn. So in our case, it is random forest classifier, and therefore we just rewrite the forest classifier. As before, we also did cross validation, and we do the same thing as previously done. You notice one thing here. We write here dot values dot travel. So if you run it without this, it will give you a warning, and it just says like you just use this dot ravel, and yeah, it's just you just write it. Just follow the instructions from the library, and if you write it, then you shouldn't get no warnings regarding the data.
So it still works, but it gives you warning. So you can just ignore warnings.
Yeah. And we can see here that the model is definitely better than decision trees. We have here F1 score of 86, and so on. Maybe we should compare them, right, Bogdan?
Yeah,
To see.
let's compare it. I prepared some code for making reports. So this few line code, what it does, it just take mean of our scores and put them in data frames. There's nothing special about that code. It's just mean. So
And we can and we can see here that random forest is always outperforming decision tree. We can see here on the third column the amount of improvement, and it's we especially in recall department there we increase like with 13%. So any thoughts you want to add?
no, so I was just want to show to agree with you that like it gives such a nice improvement, and that's even without and we didn't change any parameters in random forest. We could add more trees, and maybe we can get even higher result.
Yeah, so one thing to mention is random forest. You can there are a lot of parameters to play with them. So first of all, you can determine how many trees you want. So by default, there you will create 100 trees, and you can define which criteria you want for the decision trees. Again, you can choose Gini or maybe something different. But there are also some other things like the minimum of impurity needed, so impurity in the data to make a put a node. There are a lot of things you can change here which affect the performance of the model. However, with random forest, based on our experience, the best possible model, so like if you find the best parameters, the difference between the best and the default is not so big, and therefore it's a very versatile when it comes to that.
Mm-hmm. And the best thing, it's super fast, because you can do it multiple cores, because bunch of decision trees, so you can train every decision tree in separate thread, so making it one of the fastest models that you with. So
Okay.
if you need to prototype, this is the thing that you should work with. Okay, so the last topic for today I want to talk is feature importance. So so now we have this model, and it makes this decision, but I want to understand why it makes this decision. What is the most important? Is all data equally important? There's something that is not important, or something that is really important. And for that, there is different measurements and different ways, but today we will talk about permutation feature importance. And the idea of the permutation feature importance is very simple. It says, so what you do is just shuffle data in one column, and you shuffle, and then you train model with the shuffle data, and you see if how your accuracy changed. So if after shuffling the accuracy didn't change at all, it's probably that feature is not important, because basically what you have is bunch of random data. But if you have a problem, if your accuracy dropped, that means the feature is important. Yeah. So here's some visual help for how it would look like. So you have your test feature. So you do it for every feature. So you have 10 columns, you do it 10 times, and you get score for every feature. And so you have columns like that, and we will shuffle it and get a following result. So just random shuffle, and train your model on the shuffled data.
You make prediction on the shuffle data.
Mm-hmm. Yeah. And so that's the theory behind it, and let's look how to do it in the code. So that's why we installed the library ref pimp, because it has this functionality in one line of code, and it's very nice, so we don't have to implement anything. So again, we create a random forest classifier, we fit it, and we calculate important. And it
And
gives you nice plot.
and important here, we would do importance based on the test set and not on the train set. So that's also an important thing to notice.
Yeah.
Okay.
So now you can, Adrian, get answer for your question. Will you get a loan or not? So it seems that the most important feature is the credit history. If you have credit before or not, then it's like where you live, and then your loan amount.
Oh man, that so sucks. I felt like this is so hard because I never had the credit before. So it seems like
So
that's the
maybe
most important
you
feature.
should first apply for credit, then you pay the credit, and next time you apply for big credit.
Okay. Thank you for
That's
that's a good advice. Thank you, Bogdan. I think if I continue this way, I will get a small credit, and after 5 years, I will get the big credit.
yeah.
Perfect.
So yeah, subscribe for my new course, Financial Advice from Bogdan.
Financial independence with Bogdan.
Okay, so that's all from theory today. So I think, Adrian, we should actually the scikit-learn that we're talking so much about it, and show the homepage of this great, amazing library, which is basically the reason why we have jobs.
Yes, if it was not for scikit-learn, I don't know if I would get my job.
Yeah, it's like we would get job, but it would be like suffering, everything. Like you, every time you need to do something, you need to implement it from scratch.
Yeah.
Scikit-learn has everything implemented for you.
I tell you, at work, it's like if I want to implement a custom algorithm, it takes me so many hours to implement it. It's not one line of code; it's more like 300 line of code, and
Mhm.
it's very good. And we have libraries which can, offer the functionality, basic functionalities, in one line of code, which is very amazing. So what we see here is we just not even scratch the surface. How would you say we?
Yeah, it's just like the thing is that machine learning is very big topic. So I hope what we achieved today is show that it's not scary to do it. That you everything is already there. It's very easy to prototype and experiment. You need to go to scikit-learn and open, let's say, classification or regression. We didn't talk about regression today, and you can go to regression. You have all documentation there.
For all the models you see here, all different models which you can explore,
Yeah.
and you
Yeah,
just click. It gives you basic explanation. I would
yeah.
recommend.
Let's go to random forest regressor, because we were talking about random forest today.
Sure, give me 1 second. Let's find it. So many models. Decision tree ensemble. We're almost there. Where is it? Huh.
Yeah,
Forest of. Wait, I'm trying to find it. There's so many models.
yeah. The easiest way is to find it in Google.
Yeah, I always like Google. I write.
Yeah,
Okay,
I
let's
just
show them.
tried that.
Let's show them, how we do it at work. So we go to
Yeah,
a good old friend Google. We write here random forest scikit-learn or sklearn,
yeah.
and here you get it immediately. The regressor here. So here we can see it explains you what parameters they are, like okay, how many trees, and it really explains you about it, right?
And in the end, there is like example even, I think.
Yeah, so after like all the description about the parameters, it shows you how you can train it. You can see here, make like a random forest, you dot fit, and that's it, and prediction. We want to warn you one thing. You see here this thing called dot feature importance. We recommend that you don't use the feature importance from scikit-learn. We recommend you that use the random forest pimp library, because we won't go into detail why, but basically it doesn't use feature importance permutation. It uses some other techniques, and they're not so ideal. So you get better feature
They
importance.
they are biased, so it's like if you have highest, it tends to prioritize high numbers. I think
Yeah,
so.
yeah, exactly. That's and also
Yeah.
not, I can't find the word.
Cover. It's like it's
Covariant. Yeah,
if you want to learn, it's easy to check it, but
yeah.
it's out of scope to
For
talk
yeah.
today.
So the question is, why did we only show decision tree around the forest? In our opinion, as told you, it's like it's the knife, it's the Swiss knife in classification and regression, and it's once you understand like the basic, as Boeing said, you can go deeper and try another algorithm. You change that one line of code, see what happens, check more content, how the algorithm works. But there are more than classification regression. You can do also unsupervised learning. So for example, clustering, where you can cluster stuff, let's say customer segmentation. There are a lot of methods here which we haven't explored. And furthermore, there are a lot of pre-processing things like the simple imputer. There are a lot of other things which you can use for preparing your data and maybe find features for your projects. If this is very confusing and you don't know where to start, Scikit-learn provides you with a roadmap. Now there are two roadmaps. I show you the first one, and it's very simple. So you start first. Okay, start, and it asks you, do you have more than 50 data points? If you don't have, then you should get more data. You see, decision trees are everywhere here. If you have more than 50, then what do you want to predict? Do you want to predict the category? If not, maybe a quantity. You can just follow this, and it tries to give you a recommendation of what model you should use if you don't know what you should use. In reality, this is a bit not realistic. Something like this should be more realistic, because the first weeks what we explored was was how to deal with data, and really there's where you spend your most of the time. So this part, the lower part here, is something, it's only 10% of your project. Most likely 90 or 80% of your project is dealing in the upper one. So you start up, okay, can you use your data? Do you have access to your data? Do you understand your data? Is your data clean? It's like that process takes so long, and you go from one, you go in circles and loop around, and once you reach that point where you understand, okay, what question I want to ask, then you arrive here. So that's why the skills you learned from the third week and the second week and from the first week are more important in the beginning, because you spend most of the time there and less time with this stuff.
Great. So I don't have anything to add to this. So should we take some questions?
Yeah, before, let's say, assignment. So as a reminder, if you want a certificate, do the final project, which we're going to talk about it next week. And you have to do all the previous assignments. So you need this. You don't need to participate in the live quizzes, because you can only do it live, so that's understandable. But what we do expect that you do all previous assignments for it. And second thing, the assignment for this week, we're gonna announce it on the weekends. Yeah, I won't mention anything about it for now, but it will be machine learning, of course. Okay, so we have a lot of questions here, which were from previous.
Yeah, I think we still have like, is it a queen question?
Yeah, I'm gonna clean it. Does this person eat avocados? Film star, scientist. I'm gonna try to answer all the questions from the Boris Johnson. That was a good one.
Yeah, it was quite close.
The Queen.
Yeah,
Putin. Okay. What people are voting for.
I will take the question about cross-validation. Is the cross-validation a technique of training the model to avoid overfitting, or is just to spot the overfitting drawback? It's to spot. It's a way to evaluate your models. So all evaluation techniques are aimed to see the problems with your model. So you cannot. It's not the training method.
Okay. So, okay, pinned answered. Okay, so next question now. Now we've got it. Now we reach the point. So, will there be another lecture next time? So, yes, next week. Next week, Thursday, we're going to talk about the final project. We're going to demonstrate you a project, and then we're going to talk about common pitfalls. So, definitely next week, there's one more session, and there will be...
It's quite important, because we'll talk how to submit project, and suggest, maybe provide some data for projects that we suggest. So yeah, there will be a session, of course.
So next Thursday at 5 GMT plus 2. Okay, next question from Fairhot. I don't have the same scoring result as you. Is it normal?
Yes, it is, because of random seeding a lot of stuff. At least it should not be far away from ours. So, if you have 80%, you should have 79, 78, or 81, 82. That's what random seed is doing. So it's possible to fix random seed for everything, and then you would have same results. But random first. Random is in the name.
XX has asked, now we have trained and evaluated our model, I would assume. How to use it then? So after you trained and evaluated your model, then you would go to a phase called deployment. And in that phase is like you then do predictions to solve your problems in life. So it's like if you wanted to predict forecasting, let's say if a person gets a loan or not, then the next step when you get a new application, like a new person who comes to wants to see if they get a loan or not, you just put their data in and get predictions, and that's how you use it. So
the data should be in the same as trained data. So for example, if we had 14 columns, it should be same 14 columns in same. And to save model is very simple. I use Pickle for saving. You just save them, it's trained, and just put model.predict and pass the data that you want to predict.
So there's a lot of ways to deploy these models. You can even make like an API over the internet. There's so many ways to deploy it per se. But yeah, in the end, it's like you just once you train the model, you just make predictions with it, and that's it.
So save, open, predict. That's how it would work.
Okay. Next question is from Jonah Kado. If I run this function, I get this error, categorical. So I want to... Okay, you're getting two errors. So first of all, Jonah Kado, first, have you run... you have to run the previous commands in the beginning to import the libraries. And if you get an error there, the question is, did you download the notebook, or are you running it from Google Colab? So if you run it from Google Colab, that's very weird. Please contact us. We can look further issue. If it's, however, on your personal computer, it's not, then we cannot guarantee anything for that. Okay. Next question for Anonymous. How can I deal with a high amount of levels, like 1 million colors, would make the data frame very high dimensional?
Yeah, that's...
So this is a very common problem, especially in the world of language, where you would have like millions of words and you would do something like this. So there are some ways to deal with this. There are some optimizations called sparse matrices, where it would, because most of the values are 0, there's a way to reduce the memory usage by a lot, because only that value is 1, everything is 0. So there's a way to optimize the memory usage for this. But still 1 million is a lot even then. And yeah, what you would do go there is something maybe with scikit-learn may not help you.
Yeah.
Maybe there you need to use more advanced hardware techniques like
And it's also already like, closer to deep learning. You can do neural networks, but it's really, it's an advanced topic.
it's an advanced topic. But most of the time, if it's really if you have, let's say, 1,000 or 10,000, then it's possible without any problems, as there are some memory management
Yeah.
optimizations.
And then there's feature engineering, because you need to make to be sure that, like, do you need a million, or can you group them? If it's a color, maybe you can group them by tone, present them in some other way. So
Yeah.
there's no one answer for this. So it's a huge topic, and yeah, so a lot of work. Right? We always see some.
One more question. I think this is the
Yeah,
final question.
yeah,
I guess so. If someone, I think, yeah, this is definitely the last question
yeah,
for today.
yeah. So it's like, yeah. What do you say?
So first, I'm going to read out. Will we see some cases how deploy the model next time as well? Here's the thing. There's so many ways to deploy it. It depends what you want to do at the end. Is it something you run on a server or not?
So I would say we can show how to save it,
Okay.
how to open in a separate script, and how to feed the new data.
Okay.
But
Okay.
we are not showing how to put it on a server, how to make API, because that's it's out of scope. But we can show how to save it and how to feed new data.
Yeah. Okay. I think that's very very
Yeah,
realistic. I think
that's easy. And then if you understand how to save a model and you understand what is model, you can deploy it and put it on server, write some JavaScript to call it or whatever.
Yeah, there's like you can watch. There's so much content about this. We could if you can like contact us and we could show you some material later on. So we will show you next week then some deployment examples. And if you're not satisfied, just contact us. We're gonna help you out. Okay.
Great. So then we see you next week.
Yeah. Thank you everybody. Thank you everybody for sticking till the end. I hope this was really informative. If you have questions, just write us. Don't be afraid. We don't bite. And in assignments and everything, all the information, we're gonna write you this weekend. Of course, the video will be online on YouTube. All that good stuff will, as mentioned, as before, will be provided.
Like, subscribe, and hit notification bell.
Also, share it to a friend. And help us out. If you love our course, please spread it through social media. Every help would appreciate it.
Yeah.
So that's
because
it.
we need the sponsorship from Raid Shadow Legends.
We need, yeah. But okay, so I guess
we are already getting out of. Yeah. See you guys.
Goodbye.